Hello, this is going to be just a real quick video. It's to do with Zener diodes, so I'm going to go back to Zener diodes. I'm pretty sure this is actually the correct symbol, so I've been changing around what I thought the symbol was. I think it looks like that. It's a little slightly angled thing. So apparently this is another way that it has been drawn, not so common anymore, which I quite like because it's kind of like you can see a Z in the symbol, because there's a Z there. But if you remember, Zener diodes are actually just pretty much intended to be used the opposite way around to a normal diode. So they have so a diode normally you'd go the direction of the arrow, so the positive would be here and it would go towards the negative, and so that it would be the other way around. But these kind of diodes are designed for you to go against the flow essentially, and then they also have I don't know if that's the correct term, breakdown voltage. They have a sort of specific point where they will start to conduct. And so the ones that I used before for that voltage regulator was a 5.1 volt Zener diode. So once you put 5.1 volts through it, they start to conduct electricity. But I saw recently on a thread on Reddit about how these diodes, the Zener effect, apparently doesn't really work for very high voltages, like, you know, much over 5 or 10 volts or something. And so what they actually do when you have a Zener diode for a voltage that's somewhat higher than, like, say 10, I don't know what the exact number is, then they actually have internally a couple of diodes in series, and so you have basically to go through a couple of them. So say you wanted to do, let's just say you wanted to do 10.2, then you'd have two 5.1s in a row, and then you'd have to drop 5.1 for each of them, so over in total you'd have to drop 10. So this interests me because I've got a lot of these Zener diodes that are 39 and 36 volt Zener diodes. I think this is a 39 one, so this one's I'm not entirely sure. It's got 39 written on it, but then I have these 36 ones which I used on a previous project, not because Zener diodes, but as normal diodes. And this is where I'm going to get to with this video. I'm a bit nervous about these ones because the 36 ones were somewhat bigger than this. So I should have got those ones out, but I don't know where I put them. So we'll just stick with the 39s for now, and we'll try the other ones another day. I'm just a bit worried that maybe those are the ones that were doing it, because these are quite small, but we'll see. So these are much higher than 10 volts, and certainly much higher than 5 volts for Zener diodes. Well, at least I think they are. So first off, we're going to just check so I'm not actually, how many 9 volt batteries do I have on the desk? I don't think I have enough 9 volt batteries. So I don't know if I have enough voltage available to me at the moment. I've got one battery here, so that's 2. So I could get myself 18 volts if I really tried. I can't see, I had another one in my pocket. It's disappeared. So what I was going to do is I was going to put these all together in series by doing this little trick, and build up. So what would I need? I would need 5 of these. That will get me well over, because I need 4 to get 36, and I want one more to go over 36. So we could do that another day. So we're going to find out if they're 3.9. I was worried that these are 3.9 diodes. But what I'm interested in is if they are in series, then if you were to use these as normal diodes. So what I was thinking, because I've got so many of them, and I'm only doing things that usually use 5 volts. Well, a 39 volt Zener diode is pretty good because if I put things, if I'm going to use it as a diode to restrict the current to going one way, with a 5 volt circuit, they should work the same as a normal diode. Because if I was to put 5 volts in this way, nothing is going to conduct. It's going to act like a normal diode because it's not breaking, it's not past the Zener voltage, the rated voltage for the Zener diode. Well, that's what I thought, but the problem was if they're in series and I'm using them the other way round, so there's like multiple diodes, then for each diode there's about a 0.6, 0.7 volt voltage drop across. I know I'm using these terms correctly, but there's a voltage drop across these things of about 0.6 volts. And if you've got them in series, you're going to have a much greater, you're going to have 0.6 for every single diode that's in series. So if this was using like 36 is using like 5 volt Zener diodes in a row, that's a substantial voltage drop. That's like 5 times 0.6, so that's 3 volts lost. So today I'm just going to actually test what actually happens. What is the voltage drop when you do this as a normal style diode? So I'm just going to use this 100 ohm resistor, which is looking a bit weird because it's the only one that's sitting right next to me. And I can't be bothered moving all the way around and doing something else. And we're just going to use these little wires. So that's going, the orange wire is going to go into the positive, and we've got this set to 5 volts. And then we're going to take this to the negative, and we are going to check how much voltage is going through the resistor and how much is going through the diode. And then we're going to check that it's actually a 39 volt Zener diode and not a 3.9 volt. So I should plug these back in. Alright, so we should have 5 volts going through this. No LEDs today, not very exciting. Well, I'll turn the light on this one. That kind of counts as an LED. So we'll use the 20 volt setting, activate the backlight, which will turn off before I've even finished, and we will check what is going first across. So across the resistor, there should be about 4.3 volts going through, and we get, oh no, 3.4. This is not so good. 3.4 volts. So going across the diode, 0.8. Where am I losing my extra? So that's 0.8, which is more than I thought there would be. So that's a bit annoying. What if it is because this isn't a very good meter? What else have I got here? What's this one? This one looks like it's a bit higher. I don't know what this resistor is, so we'll test this resistor. We'll see what happens if it's higher than that. That's 200k. How big is this thing? Why are you not working? Seriously? Alright, well, hold on. I think it's a bit too much current going through that thing. Why is this not telling me anything about this resistor? Have I broken? I'm sure at some point. It will tell you if it's broken. Here we go. So this is 150 ohms. So we won't use the 100 ohms. Obviously that's a bit too, I've probably broken that diode now. Oh, I hate, I'm so used to the old school ones with the thicker wires that these newer ones are frustrating. Alright, so that's 150. I've got a lot of 150k ohms resistors, and I think they're the older ones, and so they've got nice thick wires. Alright. So let's just turn it back on again. Hopefully it won't cook like it just did a minute ago. We would have to, that's the wrong thing. So we've got 0.6 going through, so that's a bit nicer. And 4.35. So that's what we should have, that's what I would expect to see. So that's a nice sign. So we'll take this out and we'll turn it around. And if it is 3.9, then it will in fact conduct something. So if it's 3.9, there should be 1.1 across the resistor, and there isn't. So it's 4.3. That's a bit worrying. So this is what I get stuck on, is why does this not measure the way that it should? Because there's nothing going through it, of course. There's no current. But that's always kind of interesting, right, isn't it? So I guess that's just a thing with the capabilities of the meter, that this says there's 4.3, but there's definitely about 5 volts going across both components. But if you measure just across here, because there's no current going through this thing, I guess there's 0 volts across it. But there's a missing 0.37 volts or 0.65 volts here. From the reading. So I don't know, maybe if I had a fancier meter. I do have a fancier meter than this. I have to dig it up, and so we can actually compare. And I've got a whole bunch of cheap ones I've just got recently, and I wanted to see how they compare. Cheaper than this one, so this one's a pretty cheap one. A few ones that are even cheaper than this one, and to see how they compare with this one and how they compare with the better quality one. Because I'm quite keen on, making sure that you can just spend the least amount of money possible for this hobby. But anyway, this is good. It looks like it does actually function as a normal diode for my purposes, and that the voltage drop is only about 0.6 volts, which is what you would expect. So that it doesn't look like these are in fact multiple Zener diodes in series. So I will dig up the 39 volt and try that off camera, and if it actually is different, because it is substantially larger than this, and I just assume that's just because it's a higher wattage one, but maybe it's doing something sneaky on the inside. If there is anything different, then we'll come back and I'll talk about that. But for now, that was all I was going to talk about, and thanks for watching. Very, very strange and boring, but thanks for watching, and like, share, and subscribe, and all that kind of stuff, and see you next time. Bye!